Hello, welcome to the Quotient Rule. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This is for Math 1411 Calculus at UTEP. Chapter 2 Differentiation comes from Larson's 11th edition of the text. This is technically Section 2.3, Product and Quotient Rules and Higher Order Derivatives. Part 2, of which this is, Part 2 of 3, talks specifically about the quotient rule. So what is the quotient rule? The quotient u divided by v of two differentiable functions u and v is itself differentiable at all values of x, as long as the denominator is not the zero function. Moreover, how do we find this derivative? The derivative of u over v is given by the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator, all divided by the square of the denominator, which sounds confusing, so let's look at it in a better light. All we really have in the derivative of a quotient, in terms of the words I use, is low d high minus high d low all over low squared. Low d high minus high d low over low squared. Now with the product rule, if you watched the previous lecture, we're adding and we're multiplying, so order doesn't matter. However, with the quotient rule, we're subtracting, so order matters. It has to be low d high minus high d low over low squared. Make sure you get the order of subtraction correct, and of course our denominator can't be 0. So let's use the quotient rule to find some derivatives. Here's g of t equals t squared plus 4 over 5t minus 3. I'm going to identify u of t, my high, t squared plus 4. My v of t is my low, 5t minus 3. And then I'll take the individual derivatives. The derivative of t squared plus 4 is 2t. The derivative of 5t minus 3 is 5. And if I identify my functions and find their derivatives, it's much easier to put them into the proper form. The derivative of g is low, 5t minus 3. d high, 2t, minus high, t squared plus 4, times the derivative of low, which is 5, all over low squared. Low d high minus high d low over low squared. Walk away, leave it, it's fine. Oh, we're not going to walk away and leave it. Okay, let's simplify this. If I take 5t minus 3 over times 2t minus t squared plus 4 times 5 and divide it by 5t minus 3 squared, I am not going to multiply out my denominator. I'm going to leave it in factored form. It's fine. I'm going to distribute the 2t times 5t and get 10t squared minus 6t. Make sure this negative sign distributes, so I'll have 5 times t squared, that's negative 5t squared. 5 times 4, that's negative, so a negative 20. Combine like terms, the 10t squared minus 5t squared gives me 5t squared minus 6t minus 20 over 5t minus 3 all squared. Honestly, using the quotient rule just to sharpen your skills is fine for now. It's always a good idea to stay on top of your algebra because the hardest part of calculus is the algebra. If your algebra is solid, calculus is going to be a breeze for you. If you're going to use it, simplify it. If it's just for skills, you could leave it. It's fine. If h of x equals x over the square root of x minus 1, I'm going to have low square root of x minus 1. Derivative of high, the derivative of x is 1, minus high x, times the derivative of low, so square root of x minus 1. The square root of x has a derivative 1/2, x to the negative 1/2. The derivative of minus 1 is 0, so I didn't even write it here. All over denominator squared. Square root of x minus 1 in parentheses all squared. Now if I chose to multiply this out, which I'm not entirely sure why I did, the square root of x minus 1 times 1, no big deal. The term following the subtraction, we'll have a 2 in the denominator, we'll have a square root in the denominator, and we'll have an x in the numerator, so it's x over 2 square root of x. And if I chose to get a common denominator and combine this numerator, do the work, or trust me, whichever you're feeling. It simplifies to 1/2 square root of x minus 1 all over the square root of x minus 1 squared, which is still kind of a bad way to write it. If I wanted to be more precise, I would simplify further with the square root of x minus 2 over 2 times the square root of x minus 1 all squared. If you're going to simplify it, you should go all the way. Sorry about that. If f of x equals sine of x over x cubed, my quotient rule says low d high minus high d low all over low squared. Frequently in simplifying algebraic mixed with trigonometric expressions, we'll put the algebraic expression out in front, so x cubed times cosine of x is just in the normal order there. Whereas here, sine x times 3x squared, we frequently put the 3x squared out in front so we don't accidentally multiply it by the x, which is the argument of the trig function. We can't let that 3x squared slide inside of there, because once we have x, we have to do sine to it first before we can deal with our 3x squared. So be careful with your notation, make sure you're simplifying correctly. And of course, a power raised to a power, you're going to multiply and get x to the 6 in the denominator. Alright, one last one. This is a big one. Y equals x cubed minus 2x squared plus 6x to the negative 4th all over 5x to the 8th plus sine of x. So I identify my high, my top, my numerator. U of x equals x cubed minus 2x squared plus 6x to the negative 4. And then I take the derivative of each term, 3x squared minus 4x minus 24x to the negative 5, right? The negative 4 times 6 is negative 24. Don't forget to write down the x. And subtract 1, negative 4 minus 1 is negative 5. My low, my denominator, is a 5x to the 8th plus sine of x. The derivative, therefore, is a 40x to the 7th plus cosine of x. There is absolutely no way I'm going to take the time to simplify this. And if you're using WebAssign for your class, like we do at UTEP, you don't have to simplify. It'll take it in quotient rule form. So the derivative of y is a 5x to the 8th plus sine of x, that's low. D high, so u prime, all in parentheses. Make sure you're using parentheses here. Minus high, all of u, times d low, that's v prime of x, parentheses around low, parentheses around d high. Minus sign, parentheses around high, parentheses around d low. And then all of low is squared. That is it for the quotient rule. Part 3 of this lecture, after you've watched the product rule and the quotient rule, I have a series of product and quotient rule examples together, along with some higher order derivatives. Check it out.